Okay. So yeah, so let's actually calculate the slope of some of these lines here then, right? So why don't you guys go ahead and do that? Okay, so 1 and 2, go ahead and find those slopes. Take a minute. Find those slopes. Okay. And I'll do the same. So there are two slopes, yeah? Slope for number 1 should have gotten 4 over -5. Slope for number 2 should be 2 over 1. Now, did we have to use the slope formula here to find those slopes between the 2 points? Yeah, the answer is no, right? Hunter, what could we have done instead?
Oh, I just counted.
You just counted, right? And that's really all you really have to do, right? So when you count, Hunter, which point did you start with?
Oh, I said -3, 2.
Okay, you started at the -3, 2, and then what'd you do?
I went down 4 and then 5.
Okay, so yeah, so we're going to go down 4, right, because we want to do the rise first. It doesn't really matter whether you do the rise or run first, but remember, slope is also, rise over run, so you also can count down 4. And so if you count down 4, then what number is that for the rise? Yeah, negative, right, because negative, down is a negative number. So we're going down 4, and then right, and right is a positive direction, so it's -4 over 5. Now, I calculated here, I got 4 over -5. Hunter said -4 over 5. Are these two things the same thing? Yes, right? Okay, so -4 over 5 and 4 over -5 are the same thing. Okay, they're equal. It doesn't really matter which, whether the negative sign's up top or down below, they're still equal. Okay, and the same thing is done here, right? We could count the slope. So let's see, we go up 1, 2, 3, 4, 5, right, 1, 2, 3. So it's 6 over, or against 1. Okay, so yeah, those are the slopes. Okay, so parallel lines. Okay, the slopes of parallel lines. Does anyone know how are the slopes of parallel lines related? Yeah. Yeah, exactly right. The slopes of parallel lines are equal. That's right. Now, Elizabeth, have you done work with parallel lines before, or? Okay. I don't know. You just remember that. You just know it. Well, that's good. That's exactly right. Yes, the slopes of parallel lines are equal. Okay? So that's important right there. We're going to utilize that. So, in 3 and 4, let's go ahead and find the slope of each line and determine if the lines are parallel. So let's look at number 3. Okay, so I'm going to find the slope of line AB here. So I'll say let's see, slope of line AB. Okay, and I'll set that equal to, and let's go ahead, I'll go ahead and just count this, right, because why not? It's just right there, it's so easy. So let's see, we're going to have to go rise of 2, run of 4, so 2 over 4, which simplifies to 1/2, yeah? And let's see here, the slope of CD, okay, and let's see here, so Julia, what is the slope of CD? Yeah, right. Up 2 over 4, and it's slope of 1/2. So, Julia, are these lines parallel?
Yeah.
Yep, exactly right. They're parallel. Okay, they're parallel lines. We got to be careful. I mean, you can kind of look at it and say, oh yeah, they look parallel, right? But we really got to check those slopes to make sure that they are in fact parallel, because sometimes our eyes can deceive us. Okay, so let's take a look, for example, at number 4 then. Okay, so these, I mean, you can kind of eyeball it here and see. Do these lines look parallel? Yeah, kinda, right, but not really. Like you can see, like this is definitely wider down here than it is up here, so they're probably going to intersect somewhere way up here if we extended the graph. All right, so we'll go ahead and count these slopes, though. Okay, just for ease of calculations here, so let's see here. So Shannon, what's the slope here of line AB for this one right here, number 4? Yeah, -4 over 2, which simplifies to -2 over 1, right? And then the slope of CD, let's see, let's go to Elizabeth. What's the slope of CD there? Yeah, -3 over 2, which does not simplify. And so clearly these are not the same fraction, right? -2 over 1, that's -2, is different than -3 over 2, which is really like -1.5, right? And so yeah, they are not parallel. So these are, and so the way you can write that, right? We know how to denote that real easily using our symbols. Line AB, you put the two little parallel lines there, and line CD like that. That's for this one. But then here they're not parallel. Okay, they're not parallel, right? So, all right. Okay, now what if we don't have the graphs though? What if we just have the equations, right? So we'll skip down here to the next part, okay? Remember, for equations of lines, okay, normally, the normal form that we write equations of lines in is slope-intercept form, right? There's other forms for lines, okay? For example, there's like standard form, right? And I told you about point-slope form. If you guys decide to continue your math, career in high school and you want to go on to calculus, point-slope form will be useful. But the main way we have of writing equations of lines is slope-intercept form, okay? Where m is equal to the, what does the m represent? And, yeah, it's the slope, right? And B is the, yeah, good job, Patrick, the y-intercept. We call this form slope-intercept form because when it's written this way, you have both the slope and the y-intercept of your line shown to you. So you don't even have to graph it, you can just like see it. Okay? So, looking at number 5, given the equations, y equals -3 halves x plus 5 and y equals -3 halves x minus 4, are the lines parallel? Yes, they are. Yes, they are, right? And why? Because what? Slopes are equal. That's right. So, and I guess I could say the lines are parallel because the slopes are equal. Okay. If you want to be really specific here, really kind of accurate, and the y-intercepts are different, right? Because it's not exactly, if we're going to be really precise and, kind of like detailed about our description here, just saying that two lines have the same slope does not mean they're necessarily parallel, because if they have the same slope and the same y-intercept, then they're the same line, and they wouldn't really be parallel, right, if they're the same line. So that's why you don't have to be that specific. I think I'll still accept just, if this were a quiz or like test question or something like that, I would be okay with the slopes, you saying the slopes are equal. But understand, though, that if we really want to be precise, we have to say, and the y-intercepts are different, because that's really what's truly makes them parallel. Okay, cool. All right, how about number 6? Given the equations 3x minus 2y equals 12 and 6x plus 4y equals 16, are the lines parallel? Why? So if we look at this equation, if I were to graph this line, would I say that would the line have a slope of 3 here? can I just look at this equation and say, there's my x, and the number in front is 3, so therefore the slope of this line is going to be 3. Can I say that?
No.
Yeah, why not? What's the problem with this? Yeah, it's not in slope-intercept form, right? Okay, so we can only use the fact that the number in front of the x is the slope if the equation's in slope-intercept form. And how then can we get this equation in slope-intercept form? What can we do? What kind of mathematically do we need to do here? So, yeah, we want to get the y by itself, right? We want to solve for y here. So let's see here. We got 3x minus 2y equals 12. So subtract 3x from both sides. Negative 2y equals 12 minus 3x. And then divide both sides by negative 2. I'm not going to save space here, so I'm just going to do that. So let's see here. Negative 3 divided by negative 2 becomes positive 3 halves x. Okay, so my slope's negative 6, right? Because that's the number in front. It's y equals mx plus, and there's my b. So my slope is negative 6? No, it's not. It's 3 over 2, okay? So we got to be careful here. The slope is not always necessarily the first number after the y equals. The slope is mx. So the slope is always the number that's next to the x. So if that's the m, if that's the slope, then what's this negative 6?
The y-intercept.
It's the y-intercept. That's right, so you got to be real careful here. The slope for this line, the first line, is 3 halves. So be careful there, okay? I did that on purpose because that's a common mistake that I see students make sometimes, is they think, oh, it's the front number, the first number is always the slope. No, not necessarily, okay? It's the number that's with the x, once you solve for y. Okay? And then for that second line, again, is 6 going to be our slope here?
No.
Yeah, no, we got to solve this for y too, so I'm going to go ahead and do that here, right? So we subtract 6x from both sides, so it's 16 minus 6x. Divide both sides by 4, I get 4. Let's see, y equals 4 minus 3 over 2x. Right, so the slope here is a negative 3 over 2. Okay. So then are these lines parallel? Nope. The lines are not parallel because the slopes are not equal. Because their slopes are not equal. Okay? There it is. Alright, questions on that? Parallel lines hopefully are pretty easy to see, right? It's kind of easy to like, oh yeah, same slope, makes sense they would not ever intersect because they're going to go in the same direction. Okay? Alright, cool. Next, let's flip this over here then, and we'll look at perpendicular lines. Alright, so now Elizabeth, you remembered that parallel lines, their slopes were equal. Do you remember what the relationship for perpendicular lines is? Not just when the y-intercept is equal. Nope, it still has something to do with the slope, actually. Okay, yeah, opposite what? Not just opposite, though. Mary? Opposite reciprocal, that's right. So they're going to be opposite. One will be positive, one will be negative. But then if one is positive 1/2, the other one will be negative 2 over 1. So let me write that up here. So the slopes of perpendicular lines are opposite, okay, reciprocals. Okay. So again, opposite means something like this. If you have a positive slope, then it changes to a negative slope. Or if you have a negative slope, then it changes to a positive slope. Okay, they kind of change back and forth. And then for reciprocal, okay, that's like you flip. Okay, you flip the fraction. Okay, flip the fraction. Okay. So let's take a look here at number 7 then. Okay, we're supposed to find the slope of each line and determine whether or not the lines are perpendicular. Alright, so let's see here. So, so Patrick, for number 7, let's say line AC here. So this one right here. What's the slope of line AC going to be? So you said -2. So yeah, we go down 4, right 2. So slope of AC is -4/2, or just like you said, -2. I'm going to put it -2/1 just for our benefit here. Okay, so that's the slope there. And then slope of CD, Evan, what do you say there? What's the slope of line CD, Evan? So we go from C to D. Yeah. So sorry, number 7, from C to D, what do we have to do?
You go +1/2.
Rise of +1, run of +2, right? Okay. So then, Mary, are these two lines perpendicular? Yes. Okay, good. So one slope is negative, one slope is positive. One is 2/1, one is 1/2. So they are exactly opposite reciprocals. Okay, they are opposite reciprocals. Very good. Okay, good. All right, so you guys maybe go ahead and try number 8 there. Okay, see if those are going to be perpendicular. You can kind of see it already if you just give it a good look. That they're probably not. They don't look quite right, but maybe they are. Who knows? So that's why you got to actually check the math. So go ahead and try it real quick. So I think we have a consensus here in the class. Yeah. So the answer is no. No, that's right. So it's not perpendicular. Okay. Remember over here for these two lines that were perpendicular. Okay. So AC and CD. Remember we can use our symbols to write that they are perpendicular. We'll write line AC like that. We'll draw like a little upside down, well, not a little, I kind of drew that pretty big, didn't I? But anyway, it's an upside down capital T looking thing that kind of, resembles a line or two lines intersecting at a right angle. And then CD, like that. And that also indicates that those two lines are perpendicular. But here, they are not. Okay. Cool. Oh, no, I wrote on my desk. All right. So then, let's go through here number 9 through 12, right? Given that lines A and B are perpendicular, the slope of line A is given. So all these are slopes of line A. What's the slope of line B? Okay, so let's see here. 5 slope, opposite is -5, right?
Yeah, it's opposite.
Okay, so that's the opposite. So, but is that the perpendicular slope though? Yeah, no, right. What is the perpendicular slope for this, Stephanie? Just 1/5? Yeah, -1/5 or 1/-5. Either one is fine there. Yeah, so you can do this one or this one, right? Either of those two. Okay, be careful with these. It gets a little bit like, because 5 is technically, it's not well, I mean, it is a fraction, but it's not written that way, so it's easy to kind of forget that, oh yeah, I need to flip this thing as well, right? If we wanted to write 5 as a fraction, we write it as 5 over what? Right, 5 over 1. Okay, and so let's see here. 10 should be, let's go to, so Julie, what would 10's slope be? The perpendicular slope to number 10 be? Yeah, 3/2 or 3 over 2. Good. And then how about, let's see, Mason, how about number 11? What would that one be?
Negative 3/5.
Yeah, negative 3/5, you got it. And then last one here, let's go to Drew. What would the number 12 be?
1/8.
Yeah, positive 1/8. Good job. And you don't have to say positive, right? When you just say 1/8, that means it's positive, so good. All right. All right, so 13 again. We'll plot those points real quick. So let's see here. So let's see. Point A has point 3, 6. So let's see, 3 and then 6 right there. All right, B, negative 1, 4. And then C is 4, 0. And D is 0, 8. Okay, and I'll use my, ooh, I do have a straight edge, right? Okay, if you want to get a straight edge, I have straight edges over there in the little like yellow bin there if you really want to use a straight edge or if you want to use your own. That's fine. All of your agendas have those little rulers in them too. Okay. Okay. But of course, we really don't even really need to draw the lines in. I mean, it kind of looks like a right angle, and sure enough, if we like take a piece of paper here and we kind of like stick the corner in there, we're like, it looks like pretty close to a right angle, doesn't it? Looks pretty close. But we can also count our slopes, right? So let's see here. So to go from B to A, it's going to be up to right 4. So the slope of line AB is 2 over 4, which is 1/2, right? And the slope of CD, well, let's see here. So to get from C to D, I got to go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4. So 8 over negative 4, which is then the same thing as negative 2 over 1. Okay. So then, Lindsay, are these two lines perpendicular? Yes. Right? Yes. AB is perpendicular to CD. Okay. That's our final answer. All right, so that's pretty straightforward stuff, right? Questions on any of that? All right. So a few extra problems for us to do here together, and then I'll get you guys started on your assignment. So really, it's just do that, please. Okay. Which of these here? Just want to make sure we're okay with writing equations of lines, because I don't know, it's been a while, and I know that in some of my other classes, students have had difficulty with writing the equations of lines. I'm sure we're good at that too. Alrighty. So we're going to look at this side. Part of your homework is on the back there, so we'll get to that in a little bit here. Alright, but I just want to make sure we can also write the equation of lines, right? You've seen some of these before. You've done problems like this, I believe, back in Common Core, okay? But now I just want to make sure we're good on these too. So, alright, number 1. So, by the way, when we write the equation of a line, right, our typical format that we use is slope-intercept form, right, like that. Okay, so to write the equation of a line in slope-intercept form, you need a slope and you need the y-intercept, right? So if we look here at our directions, it says write the equation of the line given that m is 4, so that's our slope, right, because that's m, through the point negative 5, 2. So let's see here. Okay, well, that doesn't seem too bad. So I get y equals 4x plus 2, right? It's pretty straightforward, right? Yeah, that's not right, is it? What I did there. It's not right, Mr. Widmeyer. You're making me write things down that aren't right. Come on. But seriously, this 2, is this a y-intercept? No. What is it? It's a y. It's just a y-coordinate, right? Okay. So that's one mistake I want to kind of like shatter here, or at least like put forth. All right, is that very often I see students. They'll get, okay, there's the slope, and aha, there's a y. That's a y. That's the y, so we just put it in for the y-intercept there. But no, the y-intercept is a very special point, right? Sometimes you'll be given the y-intercept, okay? The y-intercept has a coordinate of what for its x? What's the x-coordinate always going to be for a y-intercept? Yeah, 0. So if you have a 0 and then a blank, then this number will be the b. Okay, but that's not what we have here. We don't have the y-intercept. We just have a y-coordinate. So, can't do that. All right, so then this is all we have. Okay, is this enough information? Can we stop here? Can we say, all right, we got the equation for our line? Can we do that? Yeah, no. What do we still need to find here? The y-intercept, right? Okay, so how do we do that? What should we do here? Anybody? How can we use this point here? Yeah, this is Zishan.
Replace the y with 2 and the b with negative 5.
Exactly. Our line, the equation of the line that we're writing, has to go through this point. So that means this point must work in this equation. Okay? If we're gonna write this line, this point must work in this equation. So we'll just go ahead and plug it in. And once we plug that point in, 2 in for the y, negative 5 in for the x, well, now we have enough information to solve for b, right? We have a single variable in this equation. We can now solve for the b. And so that's why we're going to do that. So let's see here. 4 times negative 5 is negative 20. Add 20 to both sides, you get b is 22. Okay. All right, so now we're done. We've got b equals 22. We can move on to the next question, right? Yeah, no, not yet, right? So again, you got to, be careful here. We're not trying to solve for the y-intercept, right? Our final answer is the equation of a line. So you need to then finish by writing out 4x plus 22. That is your final answer. Okay, so there is the equation of that line. Okay, there's the equation of that line. All right, so any questions on that? We're all good with that? Okay, this is too easy, I guess. This is too easy for you guys. I apologize. We'll keep moving then. All right, so M. So number 2 says, write the equation of the line through the points negative 2, 7, and 4, negative 3. Okay, now we're really stuck, because we weren't even given the slope. So what should be our first kind of strategy here? Michael, what's something we can do for number 2 here?
You solve for the slope using the coordinates given.
Yep, exactly right. So we use the slope formula, right? So 7 minus negative 3 over negative 2 minus 4. Okay. Now I did y1 minus y2 over x1 minus x2. Is that okay? The answer is yeah, you can. Okay. The order of the points doesn't necessarily matter. So here I did 7 minus negative 3, but then once I choose 7 as my y-coordinate there and subtract the negative 3, I had better do negative 2 minus 4, right? You got to kind of be consistent with your order there. So let's see, 7 minus negative 3, that's like plus positive 3, so it's 10. Negative 2 minus 4 is negative 6, so that becomes 5 over negative 3. So I have y equals negative 5 over 3x plus b. Ugh, fractions. Okay. And now, guess what? It's just like that previous problem that we just did, right? We've got a slope. We've got to find the y-intercept. So I can plug in either of these 2 points. Either one, it doesn't matter, okay? If you don't believe me, I'll pick the first one. And if you want to try plugging in the second one and do your math, it should end up being the same thing. So I'll go ahead and just plug in that first point. Okay, so y is 7, Let's see, negative 2 is x plus b. Oh my gosh, Mr. Whitmire, are you serious? We have to multiply fractions? Yes, I'm very serious. We have to be able to do this. You have to be able to do this, okay? So, when you multiply fractions, okay, hopefully you remember this, right? When you multiply fractions, well, let's change this negative 2 to be over 1. Okay. When you multiply fractions, it's really easy. Actually, I think multiplying fractions is probably the easiest thing you can do with fractions. When you multiply fractions, you multiply across the top, multiply across the bottom. So negative 5 gets multiplied with what? Negative 2, so it becomes 10. And then the 3 in the denominator gets multiplied with what? 1, so it's 10 over 3 plus b equals 7. And I have to subtract 10/3 from both sides. Adding and subtracting with fractions. Alright, I'm just going to leave it like that, right? No, we can't do that. Okay. If 7 minus 10/3 is equal to b, how do we subtract fractions? What do we need? Common denominator. Thank you, Shannon. That's right. Okay, so what's our denominator going to be, Shannon? All right. Well, let me give you a little help here. So 7 is over 1, and then 10 is over 3, right? Like that's pretty clear. So between 1 and 3, what's our smallest common denominator we should get there? Anybody? Yeah, Michael. Yeah, 3. Right. Okay. So like 3, we can get 1 to become 3 pretty easily, right? I just need to multiply 1 by 3 to get 3. So that means I'll multiply this fraction here, 7 over 1. I'll multiply it by 3 over 3. Okay. Remember, 3 over 3 is the same thing as 1, right? That's the same thing. So I'm just multiplying this number by 1, so that's why it's okay, because I'm just multiplying this by 1. It's not going to change the value. It's just going to change what it looks like. 3 times 7 becomes 21 over 3 minus 10 over 3. Okay. And so 21/3 minus 10/3 is how many thirds now? It's equal to 11/3. That's right. So I kind of run out of space here, so I'll do it over here. So b is equal to 11/3. We just did fractions. No one died. That's good. Okay. Because I was here to help, I guess. Maybe if you were on your own, then you would have died. All right, so let's see here. Negative 5/3 x plus 11/3. Wow. There it is. Okay. Questions on that one? Fractions were pretty hellacious there, I guess, right? Okay. We're all good on that? No questions? Okay. All right. So number 3, we're not going to do all of number 3. We're just going to get to like, well, we'll get as far as we'll go a little bit into it, and then we'll kind of just stop because I think it's going to end up being very similar there. Okay, Keegan. So number 3. Okay. If I'm just told that I have an x-intercept of negative 2, what coordinate does that mean that I have? If my line has my equation of my line, the line has an x-intercept of negative 2. What's the coordinate for that point that I can give it then?
Negative 2, 0?
Yeah, negative 2, 0. Exactly right. Okay. And then likewise, what's the coordinate if I have a y-intercept of 8? 0, 8. Okay. I'm not going to continue on from this one because at this point it's just like the one before it. We have 2 points, and so you use, find the slope, find the y-intercept. Okay, so at that point, and then dot dot dot. Okay, you got the idea, right? So I feel like does anyone feel like they're missing out on their money's worth if I don't do that one? No one feels like they're missing out on their money's worth. No, good. Okay, good. All right, very good. And then number 4. So let's look at these because these now more directly deal with stuff that we've been talking about today. So we want to write the equation of the line in slope-intercept form that is parallel to y equals negative 3 halves x plus 6, and it goes through the point negative 3, comma 6. Okay, so again, we want to write the equation of a line parallel to this line. So how can we use that piece of information to be parallel? Yeah.
Well, you know the slope, the m has to be -3.
Our line slope has to be negative 3 over 2 because it's parallel to this guy whose slope is also negative 3 over 2. Exactly right. So it's negative 3 over 2x plus b. And our line also goes through the point negative 3, comma 6. So then how can we use that? We got m. Yep, just plug it in. Exactly. So again, I'll just, okay, 6 goes in for y. Negative 3 goes in for x. Okay. And so we get 9 halves plus b is equal to 6. Okay, we'll subtract 9 halves from both sides. So 6 minus 9 halves is equal to b. Well, again, we need a common denominator here. What's our common denominator going to be for this time? 2. That's right. So 6, if I multiply 6 over 1, if I multiply that by 2 over 2, it becomes 12 over 2 minus 9 over 2 is equal to b. And so this is 3 halves. And so I get y equals negative 3 halves x plus positive 3 halves. Okay. Ugh, fractions. They're the worst. But you only like them. You only don't like them because you don't know them. If you knew them better, you'd be like, fractions are all right. Okay. All right, last one. I'll cut you guys loose on your homework here. Okay. Write the equation of the line in slope-intercept form that is perpendicular to 5x minus 2y equals 6 and goes through the point 10, negative 3. Okay. So, again, I want to write the equation of a line in slope-intercept form that is perpendicular to this. Interesting. So what should we go about doing here then? What should be our first step here? What do we need to start with? Yeah, Tanner?
Change your slope to, you gotta make the equation into y.
Yeah, okay, and so why do we want to do that? How's it going to help us? If we solve this equation for y, how does that help us?
Because, so then you can do the slope intercept.
Yep, exactly right. We need to be able to pull the slope. We need the slope from this line. So we're going to go ahead, let's see, I'll subtract 5x from both sides. So I get negative 2y equals 6, take away 5x. And then divide through by negative 2. Okay, so you get what? Y equals negative 3 plus 5 halves x. Okay. All right, cool. So the slope of this line is what then? 5 over 2. So that means our line has to have a slope of 5 over 2, right?
No.
Yeah, no, Mr. Whitmire. No. Okay. Because we're trying to be perpendicular here, we don't use the same slope. We have to. So what will our slope be then? Yeah, Stephanie.
It would be -2.
Good job. Very good. Yep. Very good. Y equals negative 2 over 5 x plus b. Ugh, more fractions. And we got to plug in our point there, right? So negative 3 goes in for y. Negative 2/5 goes in for 10. Oh, that works out real nice, doesn't it? Because negative 2 times 10 is negative 20, but over 5 is negative 4. And we just add negative 4 to, add 4 to both sides. We get b is 1. So you get y equals negative 2/5 x plus 1. And there's the equation. Okie dokie. Okay. And if you really wanted to, and I know you're like, you guys are chomping at the bit real quick here, but if you really wanted to, you could, since you guys have graphing calculators, we could actually graph both these lines, right? We could say, all right, let's see, negative 2/5 x plus 1, and then the other one is negative 3 plus 5 halves x. Okay, so if I graph both of those, okay, Okay. They're supposed to be perpendicular, but they don't really look perpendicular. Well, that's because of the kind of like the way how the screen on the calculator is a wide screen. So it's it's stretched out some this way because this goes from 0 to 10, but this goes from 0 to 10, so it's stretched out more this way. So to fix that, if you go to zoom and then go down to square, it'll square off that, and now when I graph it, it should look perpendicular. And sure enough, it does look pretty perpendicular to me. If I put my little corner of my paper in there, you can see that looks pretty perpendicular. Okay? So, any questions on any of that? Okay, so again, if you were graphing them, it's zoom, and you have to go down to zoom square, number 5, to make it kind of like look right. Okay, to kind of squeeze things in there. Alright, if there are no questions, then on the back of the paper, you've got some problems to do, and then I have one more page for you. It's not a lot of extra. All I want you to do are the circled ones. That's it. Okay, so just the circled ones, and like I said, I got one more page.